Hey, in this video we're going to look at integration by parts. If you are wondering what this is a technique that you can use to integrate two things that are being multiplied together at the same time. So, what is it and how do you use it? All it says is that if you have the integral of u dv, this will be the exact same as u multiplied by v minus the integral of v multiplied by the derivative of u. And first you might ask, what are u and v? They are both functions that you need to know how to either differentiate or integrate throughout the question. So for example, here we have u. I'm going to say original u, and we also have the derivative of v, so differentiated v. And then what is this equal to? It is equal to an original u and an original v, so original u and v. And in this term over here, we have original v, but differentiated u. So as you can see, we're using two functions all the time, u and v, but sometimes we are using it in the original version or differentiated version. So you must be able to either differentiate or integrate u or v to be able to solve this question properly. Okay. One more thing that you have to know is that you have to memorize this formula. There is no way of doing integration by parts without memorizing this formula because it's probably not going to be given to you in a question. So you have to memorize it and know how to use it at the same time. Two more things actually that you need to know is that while you choose dv, because you'll see this when we move on to a few examples, but you have a choice as to what becomes u and what becomes dv. You have a choice on which function you call u and which function you call dv. When you choose dv, you want it to be the easier to integrate. So dv is easy to integrate because you want to integrate this to get to v because the integral of it is v. So you want to be able to find the integral of dv easily without having to think too much about it. And then for u, this u must be the function that is easier to differentiate. It becomes simpler and it becomes smaller once you differentiate it. So u is, I'm going to write it down here, u is easy to differentiate or find the derivative of. Okay, so knowing these two facts, now you can actually kind of understand what happens in the examples that we go over, but basically this is what happens and this is what you need to know. Okay, question number 1, here we have the integral of x being multiplied by ex being multiplied by dx. If you remember, the reason that we use integration by parts is that we have two functions being multiplied together in the first place. So here, the two functions are x and e of x. D of x, what that means is that you are finding the integral with respect to x, and that's something you should probably already know. Okay, so then now the first step is to figure out what you want to declare as u and dv. And if you notice, something that I did not say yet, but I had this written down already because you have to memorize the integration by parts formula. If you do not know it, you would not be able to solve any of these questions, so that as your first step, you have to memorize it and you have to be able to write this down over here. Okay, now our actual first step, like we said, is that you have to declare what u is and what dv is. Okay, so you might be wondered, we have two things here, we have u and dv, but we have three things on the left. We have x, we have e of x, and we have d of x. So this is actually a good question, but whatever you declare as dv, you must include dx with it. So I'm going to show you what I mean. Let's say I want to say that dv is equal to x. I'm going to make the x as my dv. It's not only going to be x, it must be dx, only because you included d here. So remember it by that you have to include the d here as well. Okay, so we have to include the derivative on both sides of the equation. But I'm actually not going to do this. I'm not going to include, or I'm not going to declare dv as my x. I'm going to do the opposite. I'm going to declare dv as my e to the power of x with dx. I'm going to write it down here, and then I'm going to explain why. So first, I'm going to write down that dv, like I said, is equal to ex times dx. And then obviously, if you already chose that for dv, then your other choice for u must be x. So u is equal to x. And like you saw, I'm going to do this with a color code actually. So this was my u, and then my dv, I'm going to do it in blue, was this part. We split our original integral into two parts because that's what you need to solve the actual question. Okay, now you might ask, why did I choose this as my dv and why did I choose this as u? The answer is, I chose it because if you remember in my intro, I said that you want to choose dv as something that you can integrate easily. Finding the integral of x is pretty simple, but finding the integral of ex is even easier. So whatever is easier, you have to put that as your dv because it will make life easier for you afterwards. Okay, so once again, e of x is easier to integrate, so I made it as my dv. Okay, now let's analyze what we need to do next. We kind of finished the first half of the equation. Our second half here has a few things that we do not have yet. First of all, it has a u. So I'm going to write that down here. It has a u. It also has a v. It has a v again, which we already kind of said. And then it also has a du. So it has three things, u, v, and du. What do we have so far? So far we have the u. We have it here. So we can kind of ignore this. We don't need to find it. The two other things that we actually have to find are v and du. To find v, you can easily take the integral of dv, and to find du, you can take the derivative of u. So two things that have to be done here to find what v and du are. So v and du. First, let's find v. So to find this, I'm gonna rewrite this equation actually, but du is equal to ex times dx. Once again, how do you find v? First, you have to bring the dx to the bottom of this equation. So dv over dx is equal to e to the power of x. And you probably have already seen this format before, but this would be the format of something after you took the derivative of it. So after you take the derivative of something, it usually looks like this. So right now we're trying to go backwards. So how do you find v? You take the integral of both sides, kind of like this, and then you know that the integral of this is just going to be v. And then the integral of ex is going to be ex once again, because ex is one of those functions that do not change if you take the derivative or the integral of it. And if you're wondering where the plus c is, I'm going to talk about that at the end of the example, but we're going to ignore it for now because it actually doesn't mean anything for now. Okay, so yeah, now I know what v is, which is one of the things that I needed. Now I want to find what du is. So I'm going to erase a few of these steps because we don't need them anymore. All I need to know is that I found what v is, and I'm going to put it over here. Okay, like I said, now we have to find what du is. So first, let's write down that u is equal to x. Now, how do you find du? You take the derivative of both sides. So what is the derivative of u with respect to x? Derivative of u with respect to x is going to be equal to, what is the derivative of x? Pretty simple, 1. So let me repeat that again. What is the derivative, not integral, the derivative of x? It is equal to 1. And that's literally how I found it. Okay. Now our next step is write this down as well. But the one thing that you might have noticed is that we want du. We don't want du over dx. So one last step that we have to do is bring dx to the top of this equation. So du is equal to 1 multiplied by dx, but 1 multiplied by dx is the exact same as dx. So du is equal to dx. Okay, and we are done finding everything we need. So once again, I'm going to erase all my steps. We don't need those anymore. You would usually keep them on a test, but I'm trying to make this as simple as possible, so I'm erasing them. Okay, so we found all the 4 things that we need to solve this equation, and let's actually try to do that now. So I'm going to erase some of these arrows and steps once again, just to make it clear. But yeah, now I'm going to put an arrow here. First, you have to multiply u and v. What is u? U is equal to x, and what is v? It is equal to e to the power of x. So I'm going to multiply x by e to the power of x. That's the first term over here in red. Now for the more difficult term, you always have to subtract. That is part of the formula. So subtract the integral of v. What is v? We already found that. V is equal to e to the power of x. So ex. And then what is du? Du is equal to dx. So dx over here. And we are almost done. We have one more step to go. But now we did all of this to make it easier for ourselves to integrate something that was hard to integrate to begin with. So what do we do now? We actually have to find the integral now. We can't really leave it anymore. You have to find the integral of the second term. So what I'm going to do is I'm going to rewrite the first term because that does not need to change. I'm going to rewrite down ex times e to the power of x, and then minus, what is the integral of ex with respect to x? Like we said before, the integral of ex with respect to x is ex. So I'm going to leave that there. But the one final step that you have to take note of, or you have to know, this was not a definite integral to begin with. So if you don't have a definite integral, then that means your answer must have a plus c at the end, because once again, look at my integral video. I'm going to put it in the description. But if you do not have a definite integral, you have to include the plus c because you don't know what the y-intercept is. Once again, if you are confused by that, look at my integrals video. I'm going to put it in the description. So this is our final answer, and we are done. One more thing that you could do to make it look nicer, you don't have to do this at all. I'm doing it for, once again, completeness and for it to look nice. I'm going to factor out the e to the power of x. So e to the power of x times x minus 1 plus c. And this is a very valid answer, and once again, we are done. Okay, let's move on to example number 2, where we do the exact same thing, but it's a lot more difficult to declare what u and dv are. Okay, question number 2. Here we have the integral of ln x being multiplied by dx. And as you might first look at this, you might ask yourself, how do we even use integration by parts? Because we only have one function. Usually we would need two functions, like u and dv, but in this case we only have one function, which is ln x. This is a very common trick question, which you might even see on an exam. But the trick is that there is a hidden function, which is a 1. So I'm going to rewrite this equation, or integral, as the integral of ln x being multiplied by 1 and then being multiplied by dx. And now you might see how this 1 is our second hidden function, which you might not first notice when you start this question. Okay, now your actual first step is to declare what is dv and what is u. Okay, so let's always start with dv. What is easier to integrate? I'm going to ask you this. Is 1 easier to integrate, or is ln x easier to integrate? If your answer is ln x, you would be wrong, because the original question is a derivative or integral of ln x. If you say that the integral of ln x is easier than the integral of 1, you're basically wrong, because our question is the integral of ln x. There's no point of saying that the answer is the question. So the function that is easier to integrate must be 1 times dx. This is our dv. Okay, so I'm going to write this down here. So dv is going to be 1 multiplied by dx, and then 1 multiplied by dx is dx, so dv is equal to dx. And then for the second one, for u, I'm going to say that that is ln x, so u is equal to ln x. Okay, so now we finished our first step of declaring u and dv. Our second step is to find the missing information for the second half of the equation. So how do you find the second half of the equation over here? We need a couple things. First, we need u, this first variable, u. Do we already have that? Yes. So I'm going to ignore that. We already have u, so we don't need to find what u is. Okay. Our next thing to find is v. Do we have v? Out of all this, no. So we need to find v. And in the second term, we need v once again, which once we already know we don't have, so we're going to find that. And then the second thing we need to find is du. Do we know what du is? No. All we have is u, so we can use that to find du, but so far we do not have du, so I'm going to write it down here as well. These are the two things that you actually need to find the value of to be able to solve this question. Okay, first let's find v. That's always easier. How do you find v from knowing that dv is equal to dx? First, bring down the dx to this side of the equation. So dv over dx is equal to 1. Now you have to integrate both parts, or both sides of the equation. You get that v is equal to x. And if you're wondering, okay, is this the right answer? Am I doing it right? You have to ask yourself to go backwards. So if I ask you, what is the derivative of v? Your answer must be 1. Because if your derivative, or if your original function was equal to x, your derivative must be equal to 1. So that is how you find what that is. And then we just found v. I'm going to erase this step over here because you don't need it, and I'm going to bring this to the side just so that it looks better for organization purposes. Okay, now our next step is to find what du is, which is our second function or second part that we need. If you have u, finding du is as easy as finding the derivative of both sides of that equation. So I'm going to rewrite down the equation. U is equal to ln x. Like we said, if you want to find du, find the derivative of both sides. So the derivative of u with respect to x is equal to 1 over x. If you're wondering how I got this, this requires memorization. Ln x's derivative is 1 over x. There is no other way of finding this other than memorizing it. Okay, so this is our du, but we're not done yet because you always have to bring dx to the side, because right now we have du over dx. We don't have du, so du is equal to dx over x, because all I did was I brought up the dx to the top of this equation. And now we are done and we are ready to solve the actual question. I'm gonna once again erase some of these steps because you don't need them anymore. They kind of clutter our space. And now all you have to do is solve it, but I'm first gonna bring this to the side. Okay, but yeah, like I said, let's solve this question now. First, we need u multiplied by v. So in this case, what is u and what is v? We have them both over here. So this is equal to, u is equal to ln x, so ln of x, and then v is equal to x, so all this multiplied by x. That is our first term over here. We are done that. Okay, now our second term is to subtract the integral of v du. What is v? V is equal to x. I'm going to write that down. X. And then what is du? We just found that over here at the bottom. Du is equal to dx over x. So dx over x. Okay, this is now super easy because as you can tell, we have in this integral over here, we can simplify stuff. So I can get rid of this x and this x because x divided by x is 1. So that goes away. I'm going to rewrite this as x ln x, that is my first term, and then minus the integral of dx. Okay, now you might ask, what is the integral of dx? This is as easy as it gets, but the answer to the integral of dx is the exact same as finding the integral of 1, because there is a 1 that's missing here. And what is the integral of 1 with respect to x? The answer is x. So this is equal to x ln x minus x, because this once again is equal to x over here. And we are almost done, but one step that you cannot forget, like with any indefinite integral, because this is not a definite integral, is to add the c at the end. Okay, and now we are basically done, but just for completeness, I'm going to factor out the x. So I'm going to get that this is equal to x multiplied by ln x minus 1 plus c. And now we are done. And that's basically it for integration by parts. It is pretty difficult because there's a lot of stuff happening at the same time, but the way to get better at this is by practice. And I know this might seem like something anyone would tell you, but this topic requires extra practice because you actually need to get familiarized with the ways that you want to declare as u and dv, because those are always the hardest parts. Okay, but yeah, so if you enjoyed this or if it helped you, leave a like because it would help me, but that's pretty much it.